Hi all, welcome back to Computer Organization course. We'll get started. Today we will start our discussion with fetching a word from memory or reading a word from memory. So to read a word or fetch a word from the memory, the processor it has to specify the address of the memory location, that particular memory location. Now what happens is the processor transfers the address to MAR, that is memory address register. Then the output of the MAR is connected to the address lines of the memory bus. At the same time, the processor it uses the control lines of the memory bus to indicate that a read operation is needed. So when the requested data has been received, has been received from the memory, what happens? They are then stored in MDR, and from MDR, what happens? It will be sent to other registers like IR or any other general purpose register. Okay. Now the connection for the register MDR are it's shown here. Like if you could remember the single bus organization wherein we had MDR and it had two inputs and two outputs, right? One side of the MDR was connected to the internal processor bus, the other side was connected to the memory bus, the external bus. This we call it as external bus and this we call it as internal bus. So here the input and output are separated. Okay. Now what will happen here is, okay, first we'll study about this control signals. Okay. Now this is MDR, right? Memory data register. It is connected to this internal processor bus via these two switches, MDR in and MDR out. Now MDR in, what does it specify? That means whenever this is active, this switch is active, the content from the internal processor bus are transferred to MDR. Whenever MDR out is enabled or the switch is on or it is set to 1, what happens? The content of the MDR will be transferred to the internal processor bus. Then we have MDR in E and MDR out E. Here E is nothing but external. It means E means external. Okay. So whenever MDR in E is enabled, what happens? The content from the memory bus will be transferred to that of MDR. And whenever MDR out E, out external, is enabled, the content of the MDR will be transferred to the memory bus or the external bus. So during memory read and write operations, the timing of your internal processor operation, it must be coordinated in response to that of the device on the bus. Now, the processor it completes one internal data transfer per clock cycle. That means the processor takes one clock cycle to complete one data transfer. We should understand that the speed of the operation of the address device, in our case memory, it might vary with the processor. Memory is slow compared to that of your processor, right? Now, to accommodate the variability in response time, the processor has to wait until it receives the indication that the requested read or write operation has been completed. Now, we call that control signal. We call that particular control signal as memory function completed or MFC. Okay. MFC is nothing but memory function completed. Once this signal is received, your processor will understand that either read or write operation has been completed. Okay. Okay. So I have discussed these things. Now we will consider an example. Move R1, comma R2. Now this, what does this bracket for this R1 suggest? This is an indirect mode. That means R1 contains a memory location. From that memory location, you have to take the data and then you have to move to R2. Okay, what are the steps that are needed here? First thing, what you have to do, you have to move the contents of R1 to MAR. R1 contains a memory location, remember, and that memory location has to be sent to MAR. Then what happens? Once you have the address in the memory address register, a read operation has to be performed. That is done. What is the third step? The processor has send a read operation or a read control signal. Then what is the next step? it has to wait for the memory function complete response from the memory. That means your memory should send a response saying that the read operation has been completed. So once that is done, what happens? The contents from the memory would be transferred to MDR, and the last step would be from MDR the data would be sent to R2. That means we have achieved this particular instruction. Getting it? Now we will study the timing diagram for these five instructions. Okay, I mean, yeah, for these five instructions, what is the timing diagram? So for simplicity, what we will assume is we will assume like your MAR is always active. Okay, we will assume that the output of this MAR, right, is enabled all the time. So that means enabled all the time or active all the time. Active all the time here, it means whenever you place something in the MAR, it is directly available in the address lines of the memory bus. Now here your processor is the bus master. Your processor gives the instruction and others will follow that. Okay. Now when a new address is loaded into into MAR, what happens? It will appear on the memory bus at the beginning of the next clock cycle. That means here MAR in is active all the time. Whenever you place some address in this MAR, what happens? It would be available, readily available for the in the address lines of that bus. Okay. Then a read signal is initiated. Who will give the read signal? The processor, it gives the read signal. Now this read control signal is activated at the same time. So what happens here is this signal, read signal, it will cause the bus interface circuit to send a read, memory read, MR signal on the bus. So processor says that it wants a read operation from the memory. At the same time the MR, that is memory read instruction or control signal, would be activated. Now, what we have done till here, till MR, is we have achieved these two steps. Okay, the first step and the second step we have achieved. Next, we will see about the third and the fourth one. Okay, now the instructions in the third and the fourth step can also be combined by activating the MDR in E, this signal. Okay, okay. MDR in E. MDR in E, what does it mean? It is in E means external. The content will be loaded from the memory bus to the MDR. Okay, so this is MDR. Then the data would be placed here. Once the data is placed, what will happen? That means the read signal has been completed, and the last one is whatever the contents are there, it would be from MDR, it would be transferred to that of register 2. So what we have done? We have combined this first and the second instruction in single step, third and the fourth instruction in a single step. Okay, so we have done this one here now. So yeah, I had said right, we have combined the actions 1 and 2 and 3 and 4. So what we will get here is, so first what will happen, the content of the R1 are moved out, that is R1 out. From R1 out it would be transferred to MAR in E, that means external. Then a read signal would be initiated. Once the read signal is initiated, what will happen? Once that is complete, it would be the data would be moved to MDR and it would be waiting for memory function complete. So that read is complete and it is then loaded into MDR. From MDR, what will happen? You have to move it to R2. That means MDR out, comma R2 in. Okay. So we had seen just MFC, right? Memory function complete. So here W is nothing but wait. WMFC means wait for memory function complete. Okay. Next, we will see how we can store a word in a memory. So it is same as what we had seen in the previous slides. How we can fetch a word. So it is similar to that. That is storing a word. So what will happen in while storing a word? The data is placed in MDR. From MDR, what should happen? the content has to move to the memory location. So what will happen in this case? First, the processor would store the data into MDR, then the address of the memory location would be sent to MAR, then a write signal will be initiated. What will happen then? The contents of the MDR would be moved to that particular memory location. So suppose if we have this instruction move R2, R1. So here again it is an indirect mode. It says first you have to go to R1, take the memory location, and in that memory location you place the content of R2. Then how can we write the instruction sequence? First R1 out, then MAR in. That means the content, whatever the content is present in R1, you move it to MAR. Okay. Then what will be the content of R2? You move it to MDR. R2 out and MDR in. Then instead of read, now we are doing a store operation, right? That means a write operation has to be, write signal has to be sent. Then what we have? MDR out E. Right now the contents are in MDR. So whatever the contents of MDR are there, they have to be moved to the contents of R1, that is the memory location where MAR is pointing to, and you have to wait for memory function complete. So why we need this memory function complete signal? That is because your processor will understand whether the read or the write operation is complete or not. Okay. So it is said here the processor remains at step 3 in this step until the memory operation is completed and then MFC wait for memory function complete response is received. Okay, getting it? Now we will have a quiz. What does WMFC stand for? You have got 2 minutes of time. Okay, time up. Next, we will study about execution of a complete instruction. So we had seen how to store a value to the memory, how to fetch a value. Now, the complete instruction execution we'll see from fetching, doing some operation, and moving back the result. So, if you consider an example, this one add in bracket you have R3 comma R1. This means R3 contains a memory location. You have to add the contents of the memory location with that of R1 and you have to store the sum in R1. So what are the instructions that are needed for this one? First, this entire instruction would be present in the memory. You have to fetch this one, right? Then what you have to do? Fetch the first operand, that is R3. What are the contents of R3? You have to go there and you have to get the actual data. Then you have to perform the addition, the third step. Final step is to move the sum to the R1. So these are the 4 things we have to do. First, fetching of the entire instruction from the memory. Then fetching of the first operand, that is the content of the memory location pointed to by R3, then performing the addition, and the last one is moving the result to R1. Okay. Then how can we write the instructions for that? So these are the 7 steps or the instruction control sequence that are needed to execute this instruction. Add R3, contents of the R3, comma R1. So how does our instruction fetch cycle start? The first, what it has to do, this instruction would be present in the memory, right? This add instruction would be present in the memory. So PC will point to this instruction. Then you have to get this instruction. So first thing, it starts from the PC. You have to get the content of the PC. PC is already pointing here, that is program count is pointing here. So the first control sequence here is PC out. That means PC is already pointing here. We will check, I'll explain this control sequence along with this diagram here so that it is easier to understand. Okay. So the first thing what will happen is PC out. So this PC, content of the PC are moved out on this internal processor bus. Okay. You got the content of PC. Say suppose memory location 1000. Okay. In memory location 1000, this particular add instruction is present, entire instruction is present, and PC is pointing to that. So PC out, what it does, the value 1000 will be moved out and it will be present in the processor bus, internal processor bus. The next one is MAR in. So whatever the contents of the PC which are moved and present on the internal processor bus, now it has to move to MAR. Okay, now the MAR, what it contains? It contains 1000. Then read signal is initiated. That is this address lines on the memory bus. You will initiate a read signal to the this particular location in the memory. Now in the meanwhile, what will happen is PC, it has to point to the next instruction, right? PC has to be updated to point to the next instruction. This can happen at any time during the execution. Say at this moment, our PC has to be updated. Then what will happen? The PC contains whatever they were on the internal processor bus, right? They will be again, first they'll be moved to MR, then it will also be moved to this B operand of the ALU. Okay, then we have select 4. That means where do we have the select 4? Our constant 4 is here and select control signal is here. If you select 4, what will happen? The 4, constant 4 will be moved to the A operand of the ALU, and B, it already has the PC content, that is 1000. So add signal is given then. So what will happen? 4 plus 1000, you will have 1004. Why we are using 4 here? That is because the assumption is here the word length is 32 bits. Okay. Now 4 plus 1000 is 1004. So now PC will point to the location 1004. But okay, right now the value is 1004, but PC it is not having this 1004 value. We have to move there, right? So what will happen once the add operation is done? So it will move to Z in. Remember we have switches here, Z in and Z out, right? So first the content or the sum will be moved to the register Z. So Z in through the switch. Then what we'll do? We have Z out. The content, the Z out, the Z right now has 1004. Now this will be moved to PC in. From Z you have to give the content to processor bus. Then processor bus will move the content to PC. Like this, from bus it will go to PC. So now PC will contain the address 1004. Okay. Now we will not talk about this one. Okay. After this PC in 1004 has been moved to PC. Meantime, we will wait for memory function complete. So this memory function complete signal is given for this one read. Okay. So it says the read has been finished so that your processor will understand that reading is done or fetching is done. Now what will happen? So read was initiated to read the contents of the memory location 1000, right? So this has been already read. That means you have got this MFC, right? Then what will happen in the third step is the content of that particular location will be moved to MDR. So from the memory, this particular instruction will be fed into MDR. After that, you have IR in. That means MDR, the contents of the MDR will now move to IR. Your IR, now it has the instruction, this instruction, add content of the R3 with the R1 and place the sum in R1. Your IR right now it has this particular instruction. Now what will happen is from IR, the instruction decoder and the control logic will understand that you have to get the contents of the R1, R3 and all. So control signals would be initiated. Now these first three instructions it constitute of fetch cycle. Okay, so we had seen here, right, fetch the instruction. So these three are instruction fetch, then our execution starts. Okay, now what is the fourth step? First we have to get the content of R3, what is present in R3, right? That's why it is written R3 out. Say here you have R0, so here R1 is present and somewhere here R3 is present. What do you have to do? You have to move the contents of the register 3 onto this bus. What does your register 3 contains? It is a memory location. Now from here it has to be moved to MAR, right? That's why here it is given MAR in. So the contents, that is the memory location which is present in R3, has now been moved to MAR. So once the address is present in MAR, what will happen? Again a read signal would be initiated to read that content of the memory location, right? So read signal is initiated. In the fifth step, what will happen? Okay, the read is going on, the read signal is it is executing. In the meantime, what we can do, we can get the other operand which is present in R1. So in the fifth step, what we will do, we will do R1 out. So the content of the R1 is now present in internal processor bus. Then what will happen? We have y in, we have to add, right? So whatever the contents of the R1, it will be present, it will be moved out to internal bus. From there it will move to this y register. Okay, yeah, y in, that means the content has been moved to y. Then again we have to wait for MFC, that is wait for memory function complete. Which function complete? This read function complete. We have not yet got the contents of the R3, right? Sorry, content of that memory location which is pointed to by R3. So in the sixth instruction or the sixth step, what will happen is, say suppose the read operation has been complete. So the output, the content of that memory location is again now present in MDR. Okay, so the say content was 5 and the content of R1 was 1 here. Okay, so what will happen, the 5 would be placed in the MDR. Then from MDR, where will it go? It will move to this B operand here. Okay, so the content would be moved to B. Then what we have to do, before adding we have to select Y. Why? Because if you add 4, then it would be, what it will do, it will add it to the PC content. 4 will be added to PC content. Now we have to select Y. So we have selected Y, that means the 1 would be present at the A operand of the A input of the ALU. Then we had the content of register R3, right, which has been pointed to by pointed to a memory location, that is this 5. Right now this 5 is present in the B input of value. Now this 1 and 5 would be added, the value 6 is present. Okay, add is done. Then 6 will be moved to Z register. The last step would be from this Z, it has to move to R register, that is R1 in, and the last one is end. This end, it means the instruction execution of the instruction execution has been completed and the next instruction fetch cycle can be started. Okay, getting it? How our entire instruction execution will take place. Now We had not seen this y in, right? We had purposely left it. I had not discussed this one. So this y in will come into picture only when we have branch instructions. What were we doing here? So we were incrementing the content of the PC, right? We had select 4, add, z in, z out, and all. So the 1004 content, if you would remember, that we were moving to PC. Now this y in, suppose the 1004 content, first it was moved to PC, then again to y in. So whenever we have this content of the PC in y in, what will happen is whenever you have the branch instructions, your PC has to jump back or move forward, right? So for that purpose, we are using this y register to jump or to move forward in the branch instructions. Right now, in while executing this particular instruction, you do not need this y in. Okay. That's it for today. We'll conclude our session. Thank you.